Chapter 8, Section 4 is entitled Polygons and Angles. We've got two definitions here. First one is the definition of a polygon. A polygon is a closed figure, closed meaning simply that all the sides of the shape connect. There's nothing that's open somewhere. A closed figure whose sides are line segments that intersect only at their endpoints. A closed figure whose sides are line segments that intersect only at their endpoints. Regular polygon. Polygon with angles having the same measure and sides measuring the same length. A polygon with angles having the same measure and sides measuring the same length. So in a regular polygon, all the sides have to measure exactly the same thing. All the angles have to measure exactly the same degree. Regular polygon, not necessarily true. All right, again, polygon, a closed figure whose sides are line segments that intersect only at their endpoints. Regular polygon, a polygon with angles having the same measure and sides measuring the same length. Now, a lot like homework from the last couple days, a lot of what you're going to be doing here is just simple identification stuff. So in the next column, I give you all the different polygons. Now, we talked about the four-sided polygon yesterday. We spent all day yesterday talking about all the four-sided polygons, all the different. Those are called quadrilaterals. Five-sided, you should know, especially if you're a Washington, D.C. person. Five-sided shape is called a pentagon. P-E-N-T-A-G-O-N, pentagon. Now, technically, I should point out, though, it doesn't matter how it's drawn as long as it has five sides. So if you draw it looking like a house, you know, three sides in the roof, triangle roof, right? That's still a pentagon. As long as it has five sides, we call it a pentagon. It doesn't have to look like the building in DC to be considered a pentagon, as long as it's got five sides. Six-sided shape is called a hexagon. H-E-X-A-G-O-N, hexagon. What I usually tell people is to think of the X in hexagon like the same X in the letter or the word six. Six, it's got an X. Hexagon's got an X. Might make it easier to remember. Heptagon is a seven-sided figure. H-E-P-T-A-G-O-N. Heptagon. Octagon, that's the one that looks like a stop sign, and if I had any artistic ability whatsoever, it would really look like one, but I don't, as you can see. Eight-sided shape is called an octagon, O-C-T-A-G-O-N. Nine-sided shape. Now, nine-sided shape has a couple different names. The old name for nine-sided shape is a nonagon, and that's the one that seems like most people of your generation know. N-O-N-A-G-O-N, nonagon. However, they've started to, and this is the way a lot of the textbooks are referring to it now, they're calling it an enagon. E-N-N-E-A-G-O-N. Enagon. Last one I've drawn, my 80s video game series completes with decagon, D-E-C-A-G-O-N, and that's the 10-sided. Now, there's a lot of, well, I shouldn't say there's lots. There's some other ones we have names for. It just depends on what the shape happens to be. Like, there's the name for the 32-sided one. There's a name, I think, for a 36, a 37, a couple in the hundreds, but not necessarily everything. So if we don't have a name for it, we call it an n-gon, where we replace n with the number of sides it has. For instance, if it's a shape with 2,221 sides, we call it a 2021 gon. we're not original in math. If it's 507 sides, it's a 507 gon. That, I think, is the reason they started calling a nonagon an n-agon, so you don't confuse nonagon with n-gon, because they both start with n. If you were to abbreviate, they'd come out like n-gon. Okay. Now, the numbers next to them are the numbers for the sum of the interior angles. Now, when I'm talking about the interior angles, I just simply mean the angles that make up the shape. So if I'm talking about the interior angles in my quadrilateral, I'm talking about this angle, plus that angle, plus that angle, plus that angle. You already knew that made 360 because we learned that yesterday. As you can see, it goes down the list, it adds 180 as we go down the list every time. So 540, 720, 900, 1080, 1260, 1440. Now that's not actually something, though, that you have to remember. You have to know it, but you don't have to remember it. If you can remember the formula, because there is a formula that will help you find the sum of the interior angles no matter what the size, and that's the formula at the top of the next column, this n minus 2 times 180 formula. N simply stands for the number of sides the shape has. So if it's a shape and it's got 100 sides, you change n to 100. So you're doing 100 minus 2 times 180, or 98 times 180. Now, I didn't erase that. It's going to make it hard to show that. Right. How do we get that? Well, we get that through a process known as triangulation. Triangulation is simply when you cut a shape up into triangles. That's not difficult to do. As you can see, I've got my 6-sided shape there, my hexagon. And if you want to triangulate something, what you got to do is pick a corner. And as you saw I'd already done, I'm going to pick this bottom right corner.